Lecture 6, Operations Scheduling, Part 2. After having an introduction to scheduling in the previous part, now let's continue this chapter by learning the scheduling or sequencing rules or methods. These are the common ones. FCFS is first come, first serve. So yeah, jobs are processed in the order that they come to the shop. Yeah. SPT, shortest processing time. So here, jobs with shortest processing time are scheduled first. This means that we sequence the jobs in order of their processing time, in ascending order of the processing times. EDD, earliest due date, so jobs are scheduled according to their due dates. And CR, critical ratio, here we do have this formula, due date minus current time in the numerator divided by the processing time. So as you see here in the numerator, we have the available time to process that job, and in the denominator we have the required time. So yeah, available time divided by the required time, due date minus current time divided by processing time. So here we schedule the next job with the smallest CR value. Okay, so the advantage of the CR is providing a balance between SPT and EDD, and the disadvantage of this method or this rule is recalculating each time we want to sequence. We want to position a job in the sequence. Okay, so yeah, I mean, the disadvantage of this method is just the computations that we need to do anytime that we want to schedule a job. These are the notations that we will use in scheduling problems. Tij will be the processing time of job I on machine J. But if we have just one machine, I mean the single machine case, then it will be just Ti. Okay, and release date Ri will be the releasing date of job I, due date Di, completion time of job I on machine J. We show this by Cij, and the Ci will be the time that job I is completed and will leave the system. Okay, so the completion time of job I is shown by Ci. So the make span here is defined as C max, I mean maximum between C1 to C. And if we have n jobs, so we take the maximum completion time among the n jobs, and that will be the make span or C max. Okay, and the total completion time will be sum over Ci. The float time of job I will be the completion time minus release time. Okay, so this is Fi, completion time of job I minus release time. And it will include the waiting time as well. So yeah, I mean, a part of the flow time is the processing time, and the other part will be the waiting time in the line in order to start the processing of that job. Okay, lateness of job I will be showed by Li. So Li will be Ci minus Di. So completion time minus the due date. So this could be positive or negative, right? If we have delay, then Ci will be greater than Di. So it's positive, right? But if we are completing this job earlier than the due date, then it will be negative. So because of that, we have two more definitions here. Tardiness of job I, T, we show this by Ti, and it will be the positive part of the lateness. So maximum between Ci minus Di and 0. So it will be the positive part of the lateness, and we call this as tardiness. Okay, and the earliness, if we complete the job earlier than the due date, it's earliness. So earliness of job I will be the negative part of lateness actually. So in order to have a positive number here, so we define this as maximum between di minus ci and 0. Okay, and the waiting time will be wi. So now let's have the details of the sequencing rules. SPT, shortest processing time. So here we schedule the jobs in ascending order of their processing time. So shortest first, okay? And so here we have a theorem that SPT will minimize the mean flow time. So yeah, if our criteria in any scheduling problem is minimizing the mean flow time, then the optimal method there will be SPT. Okay, and also in single machine sequencing, SPT will minimize the mean flow time and mean waiting time and mean lateness as well. Okay. EDD or earliest due date here same as SPT, but here we schedule the jobs in ascending order of their due dates. Okay, so this will be our scheduling. Let's have an example here. Here we assume that we have a machine and we have 5 jobs. So these are the jobs and we have the processing times here and also the due dates. And we want to schedule these jobs using the 4 methods of FCFS, EDD, SPT, and CR. Okay. Let's start with FCFS. So here we assume that the numbers that we assign to the jobs are based on their arrival. So job number 1 is the first arrival, and then the second arrival is 2, and so on. So this is the order of based on first come, first serve. Okay, I mean the order of arrival. Now in FCFS we will schedule the jobs based on first come first serve. So because of that, the first job will be job number 1. Okay, so here we assume that the current time t is 0. Okay, so the first job will be job number 1, so it takes 11 days. So 0 plus 11 will be 11. So this will be the completion time of job 1. So the due date is 61, so there is no tardiness here. So here for the second job, the current time is 11 and it takes 29 days. So 11 plus 29 equals 40, right? Yeah, the completion time for the second job will be day 40 and the due date is 45. Again, there is no tardiness. So for the third one, 40 plus 31 equals 71. So as you see here, the due date is 31. So the due date is 31, and so because of that, we will have 40 days as tardiness or delay here. Okay, and the fourth one is 1. The processing time is 1 day, so 71 plus 1 becomes 72. The due date here is 33, so there will be 39 days as delay or tardiness here. And the last one takes 2 days, so the completion time becomes 74, and due date is 32, so there will be 42 at the tardiness here. So in total, we will have 121 tardiness here. Okay, as you see here, 121 is the total tardiness in this problem. So the mean follow time here, we can calculate the mean follow time here. So if we take the total, I mean the sum over the completion time, which is 268 here, and then if we divide this by the number of jobs, it will be the mean flow time. Okay, it's 53.6 days here. And the average tardiness, we have the total tardiness as 121, and again if we divide this by 5, the number of jobs, it will be the average tardiness, which will be 24.2. Okay, and the number of tardy jobs here, we have three jobs that have tardiness, so the number of tardy jobs will be 3 here. Okay, so this is the schedule based on FCFS, and we see the performance measures here. Okay, now let's go for EDD, earliest due date. So here we have the due dates. If we order the due dates in ascending order, we will have this order: 31, 32, 33, 45, 61. 31 is job number 3, 32 is for job number 5, and then 33 job number 4, job number 2, and job number 1. So as you see here, this is our sequencing. We will process first job number 3, and then job number 5, and then job number 4, and so on. Okay, so same as before, we do have the processing times. We can calculate the completion times and also the tardiness. So as you see here, we have let me show this a different color. Yeah, we have 4 tardy jobs, see, and the total tardiness here is 33, and also the total, sum over the completion times is 235. Okay, so now we can calculate our criteria here. Performance measures. Mean follow time will be total completion time divided by the number of jobs. It will be 47 here. The average tardiness, total tardiness divided by the number of jobs, it will be 6.6 here, and the number of tardy jobs is 4 in this case. Okay. SPT, shortest processing time. So here we order the jobs in ascending order of their processing time. So as you see here, the shortest processing time is 1, and then 2, 11, 29, and 31. So by this sequence, we will process job number 4 first, and then job number 5, and then job number 1, and then job number 2, and in the last job number 3. Okay, so yeah, again, same as before, we can calculate completion times. We do have the due dates, and then we can calculate the tardiness. So I see here, just one job has delay or tardiness. Okay, so the total tardiness here is 43 among all 5 jobs, and the total completion time here is 135 among all 5 jobs. So the mean follow time here becomes 27, and the average tardiness here becomes 8.6, and the number of tardy jobs here is just 1. Okay. Now let's go for CR, or critical ratio rule. So here at first we need to calculate the CR ratio for all jobs, and then pick the smallest one. Okay, so the CR here is this due date minus current time divided by processing time. Okay, so for job number 1, so the current time at first is 0. Okay, so for job number 1, as you see here, the due date is 61. Okay, so 61 minus 0 divided by 11 is the processing time, so this becomes 5.545. Okay, so same for the other jobs. We calculate the CR ratio, and as you see here, the smallest one is this 1, right? And it relates to job number 3, so this means we should schedule job number 3 as the first job in our scheduling. Okay, so now if we schedule job number 3 first, its processing time is 31, so the current time jumps to 31. So yeah, here we have a scheduled job number 3, just one job in our scheduling, and the current time uh, jumps from 0 to 31 because the processing time of job number 3 is 31 days. Okay, so now the current time is 31, and again we need to calculate the CR ratio for the remaining jobs. So here we have jobs 1, 4, 2, 4, 5, and we do the calculations. Due date 61 minus current times 31 divided by 11 becomes this number, and same for uh, the other jobs. And as you see here, the minimum is for job number 2. So the second job here will be job number 2. As you see here, their processing time is 29. So 31 plus 29 will be 60, right? Yes, 60. So 60 will be the current time for the third job. Okay. So now we are at time 60 and we have 3 jobs left. So we recalculate the CR ratio for these 3 jobs, and we have the numbers here. So as you see here, the CR ratio for 2 jobs, 4 and 5, are negative. When we have negative CR, so this means that these jobs will have delay, they will have tardiness. So they are given priority and will be scheduled next. Yeah, we will give priority for these jobs in order to minimize the tardiness. So for these jobs, we will schedule them in SPT order. Okay. So yeah, here I mean the smallest CR is not working, and so when we have negative numbers, we will sort the jobs with negative CR in SPT order, and then that will be our sequence. So here, job number 4, because of the processing time, job number 4 is 1, 5 is 2, so 4 will be the next, and then after 4 it will be 5. Okay, so 4 and 5 will be the next jobs in our schedule. Since after scheduling 4 and 5 we have just one job left, so we don't need to calculate anything here, and so job number 1 will be the last job in our schedule. Okay, so at the end, this will be our schedule based on CR rule, critical ratio rule. So first is 3, and then 2, then 4, 5, and 1. Okay, so now we can do the same calculations as other rules. We have processing time, we can calculate the completion time, and then we have due date, and we can calculate the tardiness. So as you see here, 4 jobs here have tardiness, and the total tardiness here is 87, and the total completion time here is 289. So the mean follow time, 289 divided by 5, will be 57.8. The average tardiness here, the total tardiness, which is 87 divided by the number of jobs 5, will be 17.4, and the number of tardy jobs is 4 here. So now we can compare the performance of the 4 scheduling rules here. So we have the final results here. So if our criteria is minimizing the mean flow time, so as you see here, the SPT provides a better schedule, right? And or if we want to minimize the average tardiness, the EDD provides a better sequence. Or if we want to minimize the number of tardy jobs, again SPT will be the case. So based on our criteria, we can see which rule actually works better in that case. Okay. So as an additional information here to wrap up the scheduling, the scheduling is not just applied in a manufacturing environment, I mean job shop or fellow shop. It can be applied for other areas like personal scheduling or course or examination scheduling in university, or vehicle routing and scheduling, and also in project scheduling. So yeah, I mean, scheduling is not just about a manufacturing environment. It can be applied anywhere that we have some tasks or jobs or things to do, and each has a time, and we have an available time. So yeah, for sure, there we can apply the scheduling methods. And at the end, to wrap up the scheduling here, the scheduling problem can be defined in deterministic or stochastic uh, environment. So in deterministic, we assume that all the jobs are certainly known, and the processing times are certainly known. Everything, I mean, the due dates, all are certainly known. But in stochastic, instead of knowing certainly those data, we will have their distributions, and so because of that, we can actually consider the expected values to minimize by the sequencing rules. Okay, so that's it. We are done on scheduling. In the next part, we will have the assembly line problem. Okay, thank you.